Okay, so today we're going to be starting chapter 4.3. This involves simplifying and evaluating expressions, or not evaluating, but simplifying irrational expressions. A rational expression, for lack of a better name, is just an algebraic fraction. Okay, and if you have a single algebraic fraction like this, so just a single algebraic fraction like this, you simplify it by seeing if there's any factorization possible for either the top and or the bottom. Right, so start there. Taking a look at the top, looking at its structure, I notice this is a difference of two squares. We have a binomial structure, so there are three special forms of factoring for binomials. This one happens to be the difference of squares factorization form because we do have opposite signs. 4 is a perfect square, x squared is a perfect square. So the top factors to 2 plus x times 2 minus x. Okay. That's how long a difference of squares factoring should take you. It's a recognition first, write the answer second, process. Okay. Perfect square minus perfect square, square root minus square root plus square root. The bottom is a quadratic trinomial structure. Coefficient of x squared is 1, so it's the easy quadratic trinomial expression. So we're looking for numbers that multiply to make negative 10, that add to make positive 3. That'd be x plus 5 times x minus 2. So if I'm trying to simplify a rational expression, I want to do factoring. Get the top something times something, the bottom something times something, everything factored as much as possible. And then what I'm looking for is a common factor. I'm looking for something that's exactly the same on top and bottom. If it's there, great. If it's not, then it might be able to be modified a little bit so it can be factored still. Right? What I'm looking at specifically here when I'm doing this is I'm noticing that this guy here, 2 minus x, and this guy here, x minus 2, look pretty close. What's wrong is the one on top, the 2 is positive, the x is negative. On the bottom, the x is positive, 2 is negative. I need them to be exactly the same. Those aren't exactly the same. Okay. Well, there's no equals to happening here, but we're trying to modify expressions or modify the structure of things so they should be the same thing. Right? So when this happens, when you have the same thing but the signs don't match up, all the signs don't match up. This sign's opposite of that sign, this sign's opposite of that sign. When every single sign doesn't match up, you can extract a negative 1 out of one of those two, it doesn't matter which one. So I'm going to rewrite the top as this, negative 1 parentheses 2 plus x parentheses x minus 2. The negative 1 that I put out in front accounts for the fact that I'm changing the signs in that expression. So you guys need to become comfortable with that because it happens often enough. You just need to be able to do it. Right? The signs didn't match. I want them to match. The way you make that happen is you just change the signs, account for it with a negative 1. All right? The bottom I'm not going to mess with. I'm going to leave it as is. So it's going to stay x plus 5 and x minus 2. All right? So what I'm left with now is all the factor stuff on top. There's 3 factors altogether. Negative 1 is a factor, 2 plus x is a factor, x minus 2 is a factor. On the bottom there's 2 factors. And this particular factor here, x minus 2, matches this particular factor here, x minus 2, so those are going to cancel. That's your goal. You want that to happen.
Why did they get x minus 2 again?
Anytime you have the signs wrong, they're not the right signs, they don't match. Okay, so again, it's just a comparison thing. This 2 is positive, this 2 is negative, this x is negative, this x is positive. These two guys are exactly the same except their signs are exactly opposite of one another. If that happens and you want them not to be, just write it the same, put a negative 1 to account for it.
So kind of how we have to do like, when we have like doing x minus 3 and like to make it a positive on synthetic division or something like that.
It does not, has nothing to do with synthetic division. It's just, I don't want that to look like that, I want it to look like that. So I just write it like I like it, and I put a negative 1 to account for it.
Okay.
All right. The reason why that happens is because when you change those signs, you're changing the sign of the term. You're making, let's say this is a positive object here. You're making it negative. 2 negatives make a positive. So you create, doesn't matter what they are. If you want the signs to change to their opposite, stick a negative 1 out there.
And you want me to do it to like top?
It doesn't matter which one you do it to. Do it to one of the two. Not both, just one. Okay. So, these are now the same as they cancel. This is everything that didn't cancel. There's no more common things, right? This is not the same as that. Even changing signs doesn't make that happen. So, that's it. So then the last thing, simplify. We want to put everything back together. You break everything down as much as you can, cancel what you can cancel, then you stick it all back together. So I'm going to multiply negative through the top. So I'm going to get minus 2 minus x over x plus 5. And that is the simplified form of the expression. The other part of this question says state the domain. Okay. For our domain, we're going to write an expression like this. X does not equal something. Okay, in a rational expression, division by 0 is illegal. Okay, you cannot divide by 0. That is not allowed. All right? So when it says state the domain, I'm going back here before I did any cancellation. Right here. The denominator of this expression is not allowed to equal 0 at any point in the problem ever. So the beginning of the problem is where the denominator is completely what it is before we canceled anything out, right? The original problem, the factored form of the denominator is x plus 5 times x minus 2, and the denominator is not allowed to equal 0. If the denominator equals 0, you're dividing by 0. Division by 0 is illegal in math. You cannot do that. So you have to ask yourself, for each factor, what value of x makes this equal to 0? What value of x makes x plus 5 equal to 0? This is not a hard question. Negative 5. Negative 5 plus 5 is 0, right? So x is not allowed to equal negative 5. What value of x makes x minus 2 equal to 0? Positive 2, so x cannot equal positive 2. That's how you state the domain. You go back to the factor form at the bottom and just say what values of x make those factors equal 0. Write those down and say those are the numbers x is not allowed to be. So, simplify, the answer looks like that. State the domain, the answer looks like that. That's what you're doing in the problems tonight.